Okay, hi. Um, let's do this. I'm sharing my screen. Okay, I can never figure out how to play it. Okay, slideshow. Okay, I'm gonna start now. Okay, so I'm an English major, and here's what I understand about the Big Bang Theory. I've really done my best, so bear with me. So, what is the Big Bang Theory? The Big Bang Theory basically explains the existence of the universe from its earliest known periods to what we know today. The Big Bang Theory describes how the universe expanded from a single hot, dense state and has since expanded and become less dense and cooled down and kind of what's around us now. So there's four main pieces of evidence that support the Big Bang Theory. And these are like little illustrations that just kind of demonstrate it. The first is the recession of the galaxies and expansion of the universe. So, the expansion of the universe and the recession of the galaxies is essentially the increase in distance between any two given parts of the observable universe with time. And technically, neither space or objects in space move. Instead, it's the space between the galaxies that's increasing. They're getting further apart as space itself expands. And then the best visual I could find for this is kind of like specks of dust on a balloon. The more you blow up, the further apart they get away from each other, and they're not changing size and they're not changing like where they are per se, but the distance between them is changing. And so that's kind of representative of um, expansion of the universe. Sorry. And our friend Hubble, Edwin Hubble, basically sums it up by saying the farther away objects are from Earth, the faster they're moving away from us. This is known as Hubble's law. So the difference in distances measured by their redshift was due to the expansion of the universe. So when they took it even further and thought that if you went back in time, the universe would look like it was shrinking, meaning that at some time in the past, all the mass of the universe was concentrated into a single point, a primeval atom, where and when the fabric of time and space came into existence, basically like a cone. The second piece of evidence is the different appearance of galaxies far away compared with nearby galaxies. As per the Big Bang Theory, the universe is expanding at a very fast rate and continuously. All the celestial objects, like planets or stars, are moving away from each other. As the galaxies move away from each other, the wavelength of the light emitted by the stars increases, which causes the wavelength to fall towards the red part of the spectrum. This shift in wavelength is increasing as the stars and galaxies are moving away from each other. It has been observed that the fainter the star, the more distant it is, and hence more will be the redshift in the light emitted by this star. Our third piece of evidence is the abundance of the light elements. So, the abundance of the light elements like hydrogen, helium, and lithium. Scientists were trying to figure out how the elements were synthesized, and they came up with Big Bang nucleosynthesis. And synthesis means to create. So, basically, as the universe started cooling down, it was like billions and billions of degrees in Kelvin, and it started to cool down. And as it cooled down, there was less energy available to combine protons and neutrons. As the conversion slowed down and eventually stopped, there was this ratio of about 6 protons for every neutron. So the protons and neutrons, they started colliding and they made deuterium. And then the deuterium collided and they made more, and they made some of them made tritium, and then other tritiums and deuteriums, they all bounced together and they all combined and they produced helium. Thus, there existed a ratio between helium and hydrogen that made up most of the matter. Um, the Big Bang theory, nucleosynthesis theory, is the only one that explains A, the amount of helium, and B, why it exists in consistent ratios with hydrogen. Basically, the hydrogen helium abundance helps us to model the expansion rate of the early universe. If it had been faster, there would be more neutrons and more helium. And if it had been slower, more of the free neutrons would have decayed before the deuterium stability point, and there would be less helium. The fourth piece of evidence we have is the cosmic microwave background radiation. Okay, so the cosmic microwave background principle is essentially electromagnetic radiation, which is a remnant from an early stage of the universe. It's basically like old radiation or background noise, which is kind of a combination of the names. It's like background noise that fills space. Its wavelengths fit into the microwave portion of the electromagnetic spectrum, and the fact that it's uniform suggests it remains from the Big Bang. It comes evenly from all directions. The universe was opaque because photons were frequently scattered by charged electrons in nuclei. But during recombination, neutral atoms were formed and the universe became transparent to radiation. Photons don't react as strongly with atoms as they do with charged particles, so the photons were basically free to travel through time and space until some antenna guys accidentally discovered it. Um, and basically, these guys were working on like car antennas, and they heard this noise, and they were trying to figure out where it was coming from. And they didn't realize that like 50 miles away, some other guys were like trying to figure out like where this noise was. Um, and I read, I think in the book somewhere it said that they even like they thought it was a malfunction with the antenna, so they even like changed the position of the antenna, and they even like put bird poop on it to figure it out. I don't know. I just thought it was funny and I thought it was interesting. So, just to recap, these are the 4 points that we went over. So, what are the problems with the Big Bang Theory? Well, one thing is that it violates the speed of light. The theory is that it started expanding faster than the speed of light. And for obvious reasons, we know that that's not possible, or at least we think it's not possible. But the people who are pro Big Bang Theory, they justify it by saying if nothing exists, like space before the Big Bang, then the laws about speed of light don't have to apply. It's basically like if nothing exists, then like you can't, it doesn't count because there's nothing to apply the law to or something. Um, I had a hard time wrapping my head around it, but that's the way that I understand it. It kind of sounds like a loophole, but whatever. It just sounds like if there's a bunch of nothingness, and then you can't really apply any laws to it, so it still counts. And it also violates the law, the first law of thermodynamics, that says energy cannot be created or destroyed. But the Big Bang Theory kind of suggests the opposite in a way. So those are just sort of like some challenges to the Big Bang Theory. So, is the Big Bang Theory a scientific idea? And to be honest, I think it depends. It's not a pseudoscience or a proto-science, um, to me. And I think it depends on how rigid you are about your definition of science. If you want to be super traditional, then no, you don't have to accept this theory because there are, there are conditions, I guess, like the problems that I talked about before. Um, But if you're willing to accept that, like, not everything makes 100% all the time, and you're a little more flexible in your understanding of science, then the Big Bang Theory is a little bit easier to understand. And I can say, as an English major, I've had to accept so many things in this class that don't make sense, just because it is the way it is. I guess what I'm trying to say is I'll accept the Big Bang Theory because I don't know, I haven't heard a better idea, and all of the evidence makes sense to me. But I guess that's why I wouldn't be a good scientist. So, yeah, that's all I got. Thank you for a great semester. I'm definitely not a science person, but I really love your enthusiasm for astronomy. And um, for the first time teaching this course, I think you did a really good job. And yeah. Um, oh, now I gotta end this. Awkward. Okay, stop sharing video. Bye.